Alright, so we are going to be talking about trapezoids and kites today. So if you are haven't done your other lessons, this is Unit 9G5, so you want to make sure you go back and get those because we are at the last one in this unit. So we'll be doing a standard check tomorrow, and then we'll review and test. So getting really close here. So a trapezoid has exactly one set of parallel lines. So this is not a parallelogram. So we've kind of been talking about quadrilaterals. Trapezoids and kites are not parallelograms here, there. And when I have a trapezoid, I have one set of parallel lines, so it kind of looks like this, and you have what are called your base angles, which are at the base. So these would be the base angles for this bottom base, and these are your base angles for the top base there. So these would then be your bases or your parallel lines. And then these are your legs of the trapezoid. So those some terminologies that we want to make sure we know before we go into this lesson. And I said those were your base angles. So bases are your parallel lines. Base angles are the angles on those parallel lines. In isosceles trapezoids, the legs are equal in length, which then makes the bases, we'll see, base angles are also equal. And then we're also going to talk about the mid segment, so that gives you an idea what that mid is, in the middle segment of a trapezoid, and what that is. And then last we'll talk about a kite, and a kite has a pair of equal sides here and a pair of equal sides here. So just some special things about a kite. So first we're going to talk about isosceles trapezoids. So the one thing that makes all trapezoids the same is this pair of parallel lines and these base angles. But in an isosceles trapezoids, the legs then are equal, so then the base angles are equal. So again, this GH is a base, and these base angles are equal to each other, and FJ is a base, and those angles are equal to each other. If a trapezoid has one pair of base angles congruent, then it's an isosceles. So if I see these angles equal, I know these sides are equal, which means then these angles are equal. And the reason that is because these are consecutive. Remember, L and K are consecutive angles, so they add to be 180. So this is 180 minus this, and this angle here is 180 minus that same amount, because M is equal to L. So then these two are equal to each other, which makes it an isosceles trapezoid. And the very last thing, so all of these are isosceles trapezoids, is if it's an isosceles trapezoid, then the diagonals are congruent. So this line is congruent to this line, kind of like a rectangle, but it's an isosceles. So here we have a basket. It's an isosceles trapezoid, so right away I should know J is equal to K, M is equal to L. These MK is equal to JL, all of those properties we just saw. So they're telling us JML, this angle here is 130, and KN is 6.7, and LN is 3.6, and we're trying to find angle MJK. So I know this angle is 130. So I can do 130 plus 130 to figure out these two angles, so 260. And I know all the angles in a trapezoid, or in a quadrilateral, add up to be 360. So if I do 360 minus 260, I get 100. And 100 divided in half are what, j and k. So j and k together equal 100, and they're equal. So if I divide that by 2, that gives me 50. Hopefully some of you are also seeing, like, since these are parallel lines, here we know that these two angles are consecutive, which means that they are consecutive angles are supplementary. So I could have also done 180 minus 130 and gotten 50 that way. So always a few ways we can solve things, and hopefully we can talk about as many of those as we can see, because different ways to see it. So here we know that JL, this whole length, is 10.3. And MN, KN, I'm sorry, is 6.7. We want to find this one. So we know that JL and MK are equal. So MK equals 10.3. And if I know part of MK is KN, so if I do 10.3 minus 6.7, then that gives me MN. Because this is 6.7, the whole thing equals 10.3. So 10.3 minus 6.7 will give us 3.6. So same thing here as we did in the last one. So see if you can figure out EFG, this angle, knowing these angles are 124. And also see if you can figure out what IH is. So try those, and then you should see your answer up here when you work those out. So last thing with trapezoids that we're going to do is look at them on the coordinate plane. So here we have this quadrilateral, and it is a trapezoid. We want to know if it's an isosceles trapezoid. So we could measure angles, but that's going to be kind of hard to do on here without some trigonometry. It's possible. But so what we need to know is, does DB equal CA? So I want to show that it is equal. Those are equal. If those are not equal, then it is not an isosceles trapezoid. So I'm going to take and find the length of CA. And the reason I know it's a trapezoid is because my slopes here are the same. It goes up 1 over 4, and this one goes up 2 over 8. And so 1 over 4 equals 2 over 8. So I can figure out those slopes. And so it's a trapezoid. So now we're going to look at what is the length of CA to see if it's isosceles. So this goes down 2 and over 1, 2, 3, 4, 5, 6, 7. So we've got 2 squared plus 7 squared. That square root is what the length of CA is using Pythagorean theorem. So 4 plus 49 equals the square root of 53. So now let's look at BD. BD equals, so to get from B to D, I'm going to go over and up. So I'm going over 1, 2, 3, 4, 5, and up 1, 2, 3, 4, 5. So I have 5 squared plus 5 squared. 25 plus 25, square root of 50. So they are not equal, so it is not isosceles. And this work is what shows you that it's not. We know it's a trapezoid because the slopes are equal, and we know it's not isosceles because the diagonals are not equal. So same thing here, check to see if it's a trapezoid first, checking those slopes of those lines that look parallel. If those are equal, then we know it's a trapezoid, and then check the diagonals. If the diagonals are equal, it's an isosceles. So try that one on your notes there. And then again, if you have questions, make sure you let me know. So one more thing with trapezoids, I think I said that was the last thing, but I want to talk about the mid segment. So mid segment is a line that's halfway between the two parallel lines. So it is also parallel. And we know, we've seen in times past, that if it's a mid segment, then it should cut both the sides in half, because that's the only way it's going to be parallel. So if the mid segment of a trapezoid is parallel to each base, and its measure, the length of it, is half the sum of the two bases, because it's the median, you can think of it in algebra terms, between these two. So if I know this length is 20 and this length is 30, that 30 is the number in between 20 and whatever this is. So 20 plus x divided by 2 equaled 30. Multiply both sides by 2. 20 plus x equals 60, and subtract 20. So that's like setting it up into an algebraic equation. I can also look at like this length, or the distance between 20 and 30 is 10. Not the distance here, but like the space between 20 and 30 on the number line is 10. So this has to be 10. So this is 10 more. So if I take 30 plus 10, that also will give me that length of GJ. So try this one. We're going to go to kites for time's sake, and then I will be here to answer any questions. So if a quadrilateral is a kite, then the diagonals are perpendicular. And again, to know it's a kite, you have two sets of equal sides, but they're not opposite, they're consecutive. So if it is a kite, then these are perpendicular. And then also, if it's a kite, then it has exactly one pair of opposite angles that are congruent. K and M are not congruent, but J and L are congruent. So knowing that property, we know that this is 121, and I want to find this angle. So all the angles add up to be 360. So I can take 121 plus 121 plus 73. That equals 315, and subtract it from 360. 45 degrees. No, it's a kite because these are equal. That makes those two equal, and then total is 360. Okay, here this is a kite, so that means that this is 90 degrees, and we want to find NP. So if this is 6, this would also be 8. So I can find NP, because this is 6 and this is 8, and this is a right triangle, by using Pythagorean theorem. So 6 squared plus 8 squared will equal NP squared. 36 plus 64 equals NP squared. 100 equals NP squared. So NP is the square root of 100, so 10. And maybe you saw that as the Pythagorean triple. So that is 10. That means this is also 10. And we need to know a little bit more information to find that one. All right. Try these last two on your own. And if you have questions, make sure you let me know. I will talk to you later. Bye.